Okay, I'm going to work out 2 empirical formulas, and then I'll do 2 molecular formulas. You have to have an empirical formula before you can have a molecular, so this is why we're going to start with it. All right, so a compound consists of 72.2% magnesium and 27.8% nitrogen by mass. So the first thing we have to do is start out with the value in grams. Then it says if you have a percent, assume that we have 100 grams. So we can say that for magnesium, we really have 72.2 grams of it. And our second step is to convert grams to moles using a T-chart. So this is going back to chapter 3. You can refer back to chapter 3 worksheets and notes if you need to. So to convert grams to moles, we have to use the periodic table. And since we're using magnesium, if we look on the periodic table, magnesium is 24.31 grams per mole. So we have grams up here. We need to have grams in the bottom. So 24.31 grams is equal to 1 mole. So we put this in our calculators. We get 2.97 moles. Now we're going to do the same thing for nitrogen. We have 27.8%, so we're going to just assume that we have that many grams. So 27.8 grams of nitrogen. Again, we look on the periodic table for the mass of nitrogen is 14.01. We have to put that in the bottom because 14.01 is in grams, and we want those units to cancel out. We have 1 mole at the top. So again, we multiply across the top, divide by the bottom, we get 1.98 moles. Step number 3 tells us divide by the smallest number of moles. So 1.98 is the smallest number. That gives us 1. And here we get 1.98, and we divide, and we get 1.5. Going to step 4, if it's a whole number, use that value as your subscript. If it's not a whole number, take it out to multiply it out to get a whole number. So 1.5, if we multiply that by 2, it would give us a whole number. Well, if we multiply the top one by 2, we have to multiply the bottom by 2. So now that we've got this down to a whole number, we can use those as our subscript. So the directions say determine the empirical formula. We've gotten our 2 values, but that's not a formula. So we know that Mg is 3, so we write this as a subscript. And then we have nitrogen is 2. I'm going to go over that last step again. We divided by the smallest number of moles. For magnesium, we got 1.5, and that's not a whole number. So we have to multiply that out to get a whole number. So what can you multiply 1.5 by to make it a whole number? And that would be 2. So this right here in this terrible handwriting says 1.5 times 2 equals, and our answer is 3. We multiply the value of magnesium by 2, we also have to multiply the value of nitrogen by 2. So down here I have 1 times 2 equals 2. And then I plug these whole numbers in as subscripts in my formula. And so Mg3N2 is my final answer. All right, let's look at the next one. Here, instead of percents, they actually give you the values in grams. So phosphoric acid is found in some soft drinks. A sample of phosphoric acid contains 0.3086 grams of hydrogen, 3.161 grams of phosphorus, and 6.531 grams of oxygen. So the starting values are in grams. We've got that. Number 2, convert grams to moles using a T-chart. So 0.3086 grams of hydrogen. If we look on the periodic table, the mass of hydrogen is 1.01, and that's equal to 1 mole. So we plug this into our calculator. we get 0.31 moles. We're going to do the same thing now for phosphorus. We have 3.161 grams of phosphorus. We look up the mass for phosphorus on the periodic table. It is 30.97 grams in 1 mole. And we plug this in our calculator and we get 0.10 moles. And then we still have oxygen, so 6.531 grams of oxygen. Look on the periodic table, the mass of oxygen is 16, and that's in 1 mole. For this we get 0.41 moles. Step 3 tells us to divide by the smallest number of moles, so that would be phosphorus. So we're going to divide each one of these by 0.1. And it says if it's a whole number, use that value. So if we divide 0.31 by 0.1, we're going to get 3.1, and that value is close enough that we can round it to the nearest whole number. This becomes 1, and then 0.41 divided by 0.1 gives us 4.1, and that one also is close enough. We can just round it to the nearest whole number. If we get anything that's 0.3 or higher, we would need to do the next step where we'd have to multiply it out to get a whole number. All right, so now that we've got these 3 whole numbers, we have to plug it into the formula. So this 3 is for hydrogen, so we're going to put H with a subscript of 3. This 1 belongs to phosphorus, so we're just going to put P. 1s are understood. And this 4 belongs to oxygen. So this is our final answer, H3PO4. And if we look in the statement, in the very first sentence, it says phosphoric acid. And if we look at the answer, we know how to name an acid and write the formula. We will know H3PO4 is the correct answer for phosphoric acid. Right, so those are empirical formulas. Next are molecular formulas. So molecular formulas, we already have to have an empirical formula. It says determine the molecular formula for each compound described. A compound has an empirical formula of NO2 and a molar mass of 92.02 grams per mole. The 2 in NO2 should be written as a subscript. All right, so it says in our directions, find the molar mass of the empirical formula. So our empirical formula is NO2. We look up the mass of nitrogen on the periodic table. It's 14.01. The mass of oxygen is 16, but we have 2 of them, so that gives me 32. If I add these 2 values together, we get 46.01. So that's my molar mass for my empirical formula. Step 2 says divide the molar mass in the problem by the molar mass of the empirical formula. Well, the molar mass they give me in the problem is at 92.02 grams per mole. So I'm going to take 92.02 and divide it by the molar mass of my empirical formula. Divide this out, and it gives me 2. So step 3, multiply the whole number by the subscripts. So our subscripts are in NO2, and we need to multiply those by this whole number. So we'll write it like this, just so. This 2 is going to go to nitrogen, and it's going to go to the oxygen. So now I have 2 nitrogen, and I have 4 oxygen. So this now is my molecular formula. That's my final answer. Right. And then the last sample problem. A compound has an empirical formula of C2H3O and a molar mass of 172 grams per mole. So step 1, find the molar mass of the empirical formula. So for carbon, I have 12.01 times 2. For hydrogen, I have 1.01 times 3. These values, I'm just getting them from the periodic table. And then oxygen is just 16. So multiply all that out. Now I add them up, and I get 43.05. Divide the molar mass by the molar mass of the empirical formula. The molar mass that they give me in the problem is 172. This gives me 4. So now I'm going to multiply 4 times the subscripts in my original empirical formula. You don't have to write this step out. I'm just writing it so you can see what my next step is. So this 4 distributes out to carbon, to hydrogen, and to oxygen. So now I have 8 carbon, 12 hydrogen, and 4 oxygen. So this is now my final answer for my molecular formula. All right, and those are all the examples that I've got for you.